Okay, guys, we're back talking about limits of composite functions. And so I want to remind you what a composite function is. So remember we did this in pre-calc. If you had like f of g of x, you had to take g of x and plug it everywhere you saw an x. So if g of x was x plus 1 and f of x was x squared, f of g of x would be, okay, I'm taking my outer function x squared, and everywhere I see an x, I'm plugging in x plus 1. So it would be x plus 1 squared, right? So we evaluated a bunch of these in pre-calc. So you have to know what they are, because now we're going to be finding the limits of them. So there is a theorem for how to evaluate them, and it basically says if the function is continuous at a point B, and you're finding the limit as x approaches a of the inner function, then the limit of the outer function is just the y value at b. So really, if you're finding the limit of a composite function, you can evaluate the limit of the inner function, and whatever the answer to that is, say 5, if you find f of 5, you will have your answer. So if you evaluate the outer function at that value. So let's do some examples. So here are two functions, f and h. So we are finding the limit of f of h of x when x approaches -2. So the first thing, remember, is to find the limit of the inner function. So h of x is here, x equals -2 is there, the limit at x equals -2 is 1. All right, now I just have to find f of 1. F of 1 is 1. So my answer here is that the limit as x approaches -2 of f of h of x is 1. All right, let's try another one. I know this feels wonky. When I was having to look this up last year, because it wasn't something I remembered, I found it a little wonky as well. And I had to do a bunch of problems, so I was like, okay, I'm kind of seeing how this works. But the second thing is, you should know this is not a major topic. If you saw it on your exam, it would be a multiple choice question. And last year there weren't any multiple choice questions, so it's not a big topic, but something we need to cover in case we see it. I don't want you guys to be like, I've never seen that before. Okay, let's try another one. This time it's g of f of x. Step 1, find the limit of the inner function. So it's the limit as x approaches -3, the inner function is f of x. Okay, here's f of x. I come to -3. There is a vertical asymptote, so that limit doesn't exist. So we cannot find the f of d and a, so this whole thing does not exist. This whole thing does not exist. Okay, we're going to talk about more what happens when you get to these discontinuities, because remember, part of this, the reason you could use this is because it's continuous. So let's talk about what happens if it's not continuous. What do we do if the theorem can't be used? So the tricky part is that in some problems, one or the other of the hypothesis, for example, continuity or the existence of the inner function, is not met, the limit of the inner function. Therefore, the theorem cannot be used. This does not mean that limits necessarily do not exist, but we need to find another way of determining them. So we need a workaround for a sense. So let's look at one. Here's a multiple choice example from 2016 BC exam. So it's saying the limit of f of this function. So this function is our inner function, g of x. So let's find out what that is. Let's evaluate the inner function. Okay, so we could easily plug that in, and we know that's going to be 1 minus 0. So this whole thing equals 1, right? Okay, but why does it equal 1? Let's remember this graph. Let's see if we remember our translations and our transformations, right? So first, it's an x squared. It's a parabola. This negative is reflecting it upside down, right? And this 1 is moving the vertex up 1. So here's the vertex. Get my pencil. And it's reflected down. So that's what that graph looks like, right? So yes, the limit at x equals 0 is 1, right? When x is approaching 0, it is 1. But we have to note here that it's from below. What do I mean? That all of the values are below x or y equals 1. And that's going to help us actually evaluate the next part. Because now, when we have to find f of 1, right, like we did in the others, You might easily go, ooh, f of 1 is 2, done, check, right? But no, we can't do that because it's all discontinuous here. Remember, that was one of the rules of the theorem. It's not continuous at x equals 1, so we cannot do that. So what can we do? Well, we're going to use this from below piece to help us. We're going to use it to evaluate x approaches. Remember, it's 1 from below or from the left of f of x. So now we are taking what we got from here, that the limit is equal to 1 from below, and changing the parameters of our limit to be x approaches 1 from the left of f of x. Well, if I approach 1 from the left, the value of that is 3, right? The limit is 3. So the answer to this thing is 3. So this is the workaround when the point you're trying to evaluate at is discontinuous. Because it's discontinuous here, we cannot do that. We have to do this. 1 from below means 1 from the left. So I'm going to leave this here. It's also posted on Google Classroom to read why. Okay, I'm going to pause it. Or you can pause it and you can read through why. Okay, this first part is going over what I said. And this second part is telling you you can actually go ahead and plug the function in, like this example from here. And if you do all that and evaluate it, you'll get 3. It's a long way to do it. And sometimes you don't know the function, so you can't do that, right? You have to be able to write the equation for this function here, which you could do. Let's try another example. Hopefully it'll make it feel a little bit better. Okay, you can see my answer up there, it's 2. Let's figure this out. So we are finding the limit as x approaches 0 of f of x. So step 1, to take the limit as x approaches 0 of the inner function, which is just f of x. Okay, as x approaches 0, f of x approaches, as x approaches 0, the limit of the function is 2, because it is approaching 2 from both sides. Again, I'm going to write from below. And why does that matter? Because I can start to see when my next step is f of 2, I can't, it's discontinuous at 2, so that's not going to work. So I have to use this from below tip to help me figure out what the answer is going to be. So now I'm going to take the limit as x approaches 2 from the left, because I'm getting it from here, of my outer function f of x. Okay, x is 2, x approaches 2 from the left, the value of that is 0. So the value of this whole function is 0. Okay, now let's go to the next example. Example 5, consider this function. The limit of f of x as x approaches 0. So this is really similar. This is the exact same problem, different graph. So step 1, find the limit as x approaches 0 of the inner function. As x approaches 0, it's 2, right? And this is from above and below. So we can't use this. How's that going to help us here, right? So then I go to f of 2. F of 2, oh, it's not continuous there, right? It's not continuous there. This doesn't help us at all because the limit is one side's coming from below, one side's coming from above. So because of that, this whole thing does not exist. We cannot overwrite this discontinuity, which is essentially what it says down here, right? There's no way to work around this discontinuity. All right, one more example. Here's a function. This is hard to see, but it says the limit as x approaches -1 of f of x. And this is an example from College Board, so here's something you might see. Step 1, find the limit of the inner function as x approaches -1. All right, the limit of the inner function as x approaches -1 is 3. And guess what? It's from below. We'll have to do an example from above next time. So then that's helpful because now when I have to find f of 3, it's discontinuous. So now I know that I can evaluate 3 from the left of the outer function, which ends up being -1. So my answer to this whole thing is -1. All right, try some practice problems and see if it starts to feel more familiar with you. I'll see you next time.